All right, this is going to be linear functions part two. In this case, we're going to be showing you different versions of linear functions and how to interpret them. Okay, so the first thing we're going to be talking about is an x-intercept. An x-intercept is the x-coordinate of the point on the graph where it intersects the x-axis. In this case, your y value is going to be 0, and your point is going to look like x comma 0 because, again, your y value is 0. The y-intercept is going to be the y-coordinate of the point of the graph that intersects on the y-axis. And when you have a y-intercept, then you know your x value is going to be 0, and that means you're going to get a point that looks something like 0 comma y. Now, x-intercepts and y-intercepts are really important when they give it to you in standard form. We'll talk about what standard form looks like, but let's just take a look at this next example. It says, example number 1, determine the x and y intercepts of the line of 5x plus 3y equals negative 6. This is written in standard form. We'll define what standard form is on the next page. But let's go ahead and find the x and the y intercept, okay? If I want to find the x-intercept of this, I told you that x-intercepts means your y value is going to be 0. Super duper important that you make that connection. If you're trying to find the x-intercept, that means your y is equal to 0. And then if you want to find your y-intercept, then that means your x is equal to 0. Why is that important? Well, because remember, actually, let me go ahead and highlight this. I'm finding the x-intercept, which I did in green. If I have an x-intercept, then my y value is 0. So when I write my equation, 5x plus 3y equal to negative 6, then I know my y value is 0. So I can rewrite it as 5x plus, there's my y. I'm going to replace it with the number 0 is equal to negative 6. I know 3 times 0 is 0, so I get 5x plus 0 is negative 6. And 5x plus nothing is just going to be 5x is equal to negative 6. I just realized that I didn't like this number and that I changed it during class. So I'm going to go ahead and change it right now. Can you do me a favor? Can you change that negative 6 to a negative 15? Because I don't want to be dealing with decimals on the very first example and then confusing you. So sorry about that. We're changing all these negative 6s to negative 15s. Just going to make this problem a little bit smoother so you can understand the concept of it. All right, so all I did was I changed my equation. It doesn't really change the concept. I'm one step away. I'm going to go ahead and divide both sides by 5. And I get x is equal to negative 3. So what do I know? I know my y is 0. I know my x is negative 3. So if I want to plot that point, I'm going to write it as x comma y. That's going to be negative 3 comma 0. Because my x is negative 3 and my y is 0. Okay, so let's go ahead and plot that. Negative 3 comma 0 is right here. Notice that the x-intercept is on the x-axis, just like I said it would be. All right, let's go ahead and do the next one. I want to find my y-intercept. If I am finding a y-intercept, then I know that my x value must be 0. Let me go ahead and highlight that. If that is the case, then I can go ahead and start writing my formula. I know that 5x plus 3y equals negative 15. Then, and again, we just said that x is 0, so this means 5 times 0 plus 3y equals negative 15. 5 times 0, that's just 0 plus 3y equals negative 15. That means 3y must be equal to negative 15. And when I divide both sides by 3, I get y is equal to negative 5. I just found out that my y value is negative 5. If I want to plot this as an x comma y, well, I know my x is 0, and I know my y is negative 5, so this is going to be at the point 0 comma negative 5. If I plot 0 comma negative 5 on my graph, 0 comma negative 5 is going to be right. Whoop, that's not true. 0 comma negative 5 is going to be down here. And in this case, we're only going to need 2 dots to plot our line. Okay, with 2 dots, that's good enough. You can keep following the pattern, and that'll be actually better. But with 2 dots, you do have enough to plot a line. So I'm going to go ahead and use a straight edge or a ruler. to go ahead and connect these. And just make sure that you use your ruler to go all the way through. Something like that. Oh, forgot the arrows at the end. Okay, so that's hopefully not too bad. Hopefully that made a lot of sense. Let's go ahead and keep going. It says determining the x and y intercepts of this line, negative 5x plus 6y equals 30 this time. Let me go ahead and start this problem off. I want to find first my x-intercept because this is written in standard form. And I know if I want to find my x-intercept, then that means that my y must be equal to 0. So let me go ahead and substitute. This is going to be negative 5x plus 6. There's my y, but I know it's going to be 0. So this is going to be 6 times parentheses 0 equals 30. 6 times 0 is just 0, so I get negative 5x plus 0 equals 30. That means negative 5x equals 30. I'm going to divide both sides by negative 5. X equals negative 6. All right, I just found out that my x is negative 6 and that my y is equal to 0. I'm going to put this as a coordinate, x comma y. So my x is negative 6, my y value is 0. I'm going to go ahead and plot that on the x-axis. Negative 6 comma 0 is right here. I'm done with the x-intercept. Let's move on to the y-intercept. If I want to find my y-intercept, then I know my x must be equal to 0. So let me go ahead and start writing my equation. I'm going to write negative 5 times parentheses, my x. But again, I know x is 0, so I get to write a 0 in its place. Plus 6y equals 30. Negative 5 times 0, that's just 0 plus 6y equals 30. 0 plus 6y is going to be 6y is equal to 30. And I'm going to divide both sides by 6. Get y is equal to 5. So now I can write my coordinate. I'm going to write this as x comma y, but I know my x is 0 and my y is 5. If I did this correctly, 0 comma 5 is my y-intercept. It should be on the y-axis. So let me go ahead and see. This is my y-axis. 0 comma 5 is right here. And sure enough, it does land on it. Now that I have 2 points, I should be able to use those 2 dots to create the rest of my line. Just make sure that you're doing this nice and straight. And there's your graph. All right, let's go down to the bottom. This is just something that I think it's easier if you just memorize. We can go through the concept of it, but just understand that if you have a horizontal line, then your equation is going to look like y equals some number, and it's going to have a slope of 0. Remember, we talked about that last time, that if you have a flat line, your slope is going to be 0. It's not going up, it's not going down. The reason why you want to write this like y equals some number was because every single y value on this line is going to be the exact same number. For vertical lines, you're going to do the exact opposite. Vertical lines, you're going to have a line that goes straight up and down, and instead of y equals a number, you're going to have x equals a number. And remember that when you have a line that goes up and down, that slope is going to be undefined. Okay? So let's take a look at example number 3. It says graph a horizontal line with y equal to 4 and a vertical line where x is equal to negative 3. I think the easiest way to do this is, since they're telling you that y equals 4, we're going to go ahead and put a dot on the y-axis at 4. I'm going to put a dot on the y-axis at 4. Now that you have that, remember that a y equals formula is going to be a horizontal line. So from that dot, you're just going to draw a flat line going left and right. This is the y equals 4 line. Now we're going to go ahead and talk about this. Why is it called the y equals 4 line? Well, just look at this point. This point right here is 2 comma 4. Look at this point. This point right here is 4 comma 4. Look at this point right here. It's 8 comma 4. You know what number you kept hearing? You kept hearing something comma 4. And that something comma 4, your y value was always 4. That's how I know that this is the y equals 4 line, because every single one of those dots on that line has a y value of 4. Let's take a look at the next one. Remember, I wanted a line that had x equals negative 3. X equals negative 3. On my x-axis, I'm going to put a dot at negative 3. So I'm going to put a dot right here. Remember that x equals is going to give you a vertical line. So you're going to put a line that goes straight up and down through that negative 3. So I'm going to start here. I'm going to go straight down just like this. This is the x equals negative 3 line. Just like before, if like, why do they call that one the x equals negative 3 line? Well, because look, check this out. This point right here is negative 3 comma 5. This point right here is negative 3 comma 2. This point right here is negative 3 comma negative 4. In every single one of those cases, you had negative 3 comma some other random number. Notice that your x value was always negative 3. And so this is why they call it the x equals negative 3 line. All those x values on that line is negative 3. So if you have a y equals a number, then it's a horizontal line with a slope of 0. If you have x equals a number, it's going to be a vertical line with a slope that's undefined. All right. Here's where we get into the heavy stuff. So here we go. There are 3 different main forms of how to write a linear equation. They're all equivalent to each other. That is to say, they will all give you a straight line. There's just different versions to write that same line. You can write them in different ways. So the one we use the least is the one we showed you earlier, the one in standard form. The one in standard form looks like this: ax plus by equals c. That is to say, both your variables are on the left, and then the random number is on the right. If you see it in this manner, then chances are the best way to graph this is to use the x-intercept and the y-intercept. So it's nice when it's this way because you know where your x and y-intercepts are really quickly. You just set x equals 0 to get your y-intercept, and you set your y equal to 0 to get your x-intercept, and you solve just like we did before. You put the 2 dots and then you graph it, okay? So that's method number 1. It's standard form when it looks like that. Method number 2, and probably the one that gets used the most, is this one, slope-intercept form. They call it slope-intercept form because it's going to be in y equals mx plus b. And this one, right away, it tells you the slope and it tells you the y-intercept right away. That makes it really easy to graph because you just put a dot on the y-intercept and then you use your slope, your rise over run, to do the rest of it. That's what we did in the previous notes, okay? And then the one that kind of gets used, like I know students like this, but I honestly really don't like this one. It's called point slope form. This one's nice when you have the slope and a point, and you're just looking for an equation. Like you're not really looking to graph it too much. You're just looking for the equation. So the point slope form is going to look like this: y minus y1 is equal to m times x minus x1, where you have a slope and x1, y1 is one of the points on your line. Okay, so here is the first example. What is the equation of a line that has a slope of 2 and contains the point 2 comma 5? Now, because they gave me a slope and they gave me a point, I'm going to start by putting this in point slope form just because they want an equation, okay? But honestly, guys, most of the time they're going to ask it in y equals mx plus b form. So we're going to change it to y equals mx plus b form. So first, let's just get a regular equation going. I know that my formula is for point slope. It's y minus y1 is equal to m times parentheses x minus x1. And what did they give me? Well, they told me that the slope is 2. And they told me that I have this point 2 comma 5, which means this is going to be my first x and my first y. Okay, let's go ahead and start plugging this in. As far as a y value, we're going to skip the y value for right now because I definitely have a y1 value. My y1 value is going to be 5. So I'm going to write this as y minus 5 equals. As far as my m, that's my slope. I know my slope is 2 times parentheses. As far as this x, we're going to skip this x because I definitely have this x1 right here. So I'm going to write this as x minus my x1 is 2. Okay, I have my y minus 5 is equal to 2 times x minus 2. This is in slope, point slope form. Point slope form. So if they just wanted an equation and they didn't tell you how they wanted it, you would be done. Okay. But again, I said I don't want it in point slope form. I want to change it to y equals mx plus b or slope intercept form because that's the one that's more general. Hey, this first time it's going to be a little bit tricky, but that's okay. It's really not that difficult. We're just going to go ahead and distribute that 2 first. I have this number in front of the parentheses. I'm going to distribute it here and here. So I still have y minus 5 is equal to 2 times x is going to give me a 2x. And then 2 times negative 2 is going to give me a negative 4. All I did was I multiplied 2 times x and I got 2x. And I multiplied 2 times negative 2 and I got negative 4. Okay, I distributed the 2. That almost looks like y equals mx plus b form. I just need to add 5 to both sides because I want to get y completely by itself. So I'm going to add 5 to the left. Hey, I'm going to add 5 to the negative 4 because those are like terms. Okay, these are going to cancel. I get y equals 2x, negative 4 plus 5. That's going to be a positive 1. And this is in slope intercept form, which is exactly what I wanted to do. So I was able to change something that was in point slope form, and I changed it to slope intercept form. Honestly, guys, if I were to graph y minus 5 equal to 2 times parentheses x minus 2, and I were to graph y equals 2x plus 1, they would be the exact same line. I'm just changing the way it looks, but I'm not changing what it is. Okay? All right, let's try the next one. The next one is definitely the hardest one that we have today, just because there's fractions involved that are not so nice. I mean, if you don't get the fractions, don't worry about it too much, but I just want you to get the concept down, all right? It says, what is the equation of the line of it has a slope of negative 3/5? So I know the slope. And it has a point 1 comma negative 1, so this is going to be my x1, and this is going to be my y1. Just like last time, because I have a point and a slope, I'm going to use point slope form. Point slope form looks like this. Y minus y1 is equal to m times x minus x1. Okay, let's go ahead and start substituting these values. I get y minus y1, which is negative 1. Remember, we need to put minus negative 1 like this. Is equal to, my slope is negative 3/5 times x minus x1. My x1 is the number 1. I see a minus a negative, so I'm going to change that to y plus 1 is equal to, and here I'm going to distribute negative 3/5 times x is negative 3/5 x. And then negative 3/5 times negative 1, that's going to give me a positive 3/5. So far, nothing tricky. Here's where it gets tricky. I want to get y completely by itself, so I'm going to subtract 1 on both sides. I'm going to subtract 1 here, and I'm going to subtract 1 here because those are both like terms. I get y equals negative 3/5 x, and I need to take 3/5 and I need to subtract 1. I can't do that because one's a fraction, the other one's not. So I'm going to put this as 1 over 1. I still can't do that because they don't have the same denominator. So I'm going to multiply that second one by 5 over 5. That gives me 3/5 minus 5 over 5. Now I can finally subtract 3 minus 5 gives me a negative 2 over 5. So this actually becomes minus 2 over 5. I fully understand that that was not fun. And I don't know what to say. You just have to learn how to do it. Okay. Okay. So we're not going to touch that. We're going to move on. The other ones shouldn't be as bad. The next one says, what is the equation of a line that passes through 3 comma 8 and 2 negative 2 comma 7? Hey, I can't use point slope because I don't know the slope. And I can't use standard form because they didn't even give me the equation. And I can't use slope-intercept because, again, I don't know the slope. So what I do know is that I have 2 points. This is x1, y1. This is x2, y2. What can we find if we have x1, y1, and x2, y2? I can find the slope, right? There's a formula that uses all those things. So that's exactly what we're going to do first. I'm going to use my slope. M equals y2 minus y1 over x2 minus x1. That's from the notes previous to this one. We're just going to substitute our values. My y2 is negative 7 minus my y1, which is 8, all over. Negative 2 is my x2, and then minus 3 is my x1. This becomes negative 15 over negative 5, and that just becomes positive 3. What did I just find? I just found that my slope is 3. So now, when I try to put this in slope-intercept form, it's going to be y equals mx plus b, but I know my m. My m is 3. I need y equals 3x plus b. I am almost done. I still need to substitute that b. I don't know what my y-intercept is. What do? I use one of these x's and y's. I'm going to use this guy. You could use this one too. It's going to work, but I like dealing with positive numbers, so I'm going to use this one. This is my x. This is my y. So when I see y, I'm going to replace it with the number 8. This is going to say 8 equals 3 times, what's my x? My x is 3 plus b. 8 equals 9 plus b. I'm going to subtract 9 from both sides. I get negative 1 is equal to b. I know my y-intercept. I know my slope. Since I know my y-intercept and I know my slope, I should put this in slope-intercept form. So instead of y equals mx plus b, I'm going to write this again, but this time I'm going to write y equals, my slope is 3x, and my y-intercept is a negative 1. There is my equation in slope-intercept form. Make sure you put your slope and your y-intercept in order for you to get full credit. Hey, we're down to the last one. We're going to do exactly what we did before. I have 2 points. That means this is my x1, y1, x2, y2. I am going to use those numbers to find my slope first. So I'm going to get m equals y2 minus y1 over x2 minus x1. M equals, my y2 is negative 2 minus, my y1 is 3 over x2 is negative 4 minus x1 is 1. That means my slope equals negative 5 divided by negative 5. That means my slope is equal to 1. So when I write my equation, I'm going to write y equals, instead of mx plus b, I know my m is 1x plus b. I know my m, I don't know my b. How am I going to get my b? Just like last time, I'm going to use one of these sets. I don't care if you use this one or this one, just be consistent. I like small positive numbers, so let's go ahead and use this one. So I know my y is 3 is equal to 1 times, what's my x? My x is 1. Plus b. 3 equals 1 times 1 is 1 plus b. Subtract 1 from both sides. 2 is equal to b. Don't stop there. Write the equation now that you know your slope and your y-intercept. Put it in slope-intercept form. So I'm going to write y equals 1x plus my b, which in this case is 2. We don't write 1x ever, so I'm going to change that 1x to y equals x plus 2. And this is my equation in slope-intercept form. That is all the notes for today. If you have any questions, as always, feel free to ask.